Archificial intelligence. Behold the world's first 100% AI architecture project. The Lake-Blood Estate will legitimize AI as an architectural asset by demonstrating its ability to produce practical, appropriate, and by golly, gorgeous solutions. Don a smile, recappers. Our lead story is off to the region that dominates global happiness reports like Queen Bey dominates award shows. We're talking Sweden and a Gaussian Splatting initiative from a preeminent automotive manufacturer. But if you thought this was Volvo's first innovation rodeo, you'd be as wrong as thinking the Danes were downers and the Finns fussers. Because even though digital transformation still eludes many an organization, the Swedish car connoisseurs were onto it nearly a decade ago. So, there's this EU-backed InTalk thing in 2016, an engineering toolchain for efficient and iterative development of smart factories, to which Volvo was magnetically drawn. It got Alliance happy and began the ambitious, maybe crazy for the time, journey of creating a virtual twin of their factory in Umeå, Sweden. The project's chief pursuits were dynamic virtual engineering of production systems, real-time data feed for factory preparation and simulation, and operational monitoring utilizing partnerships. The scanning and CAD work on the production cells were grueling and tedious given the size and intricacy of the factory, but that only heightened the satisfaction of experiencing a true digital replica and the unending testing that could occur without disrupting production. As the project progressed, the Umeå factory became a hub of innovation, drawing industry-wide attention. And within the Volvo mission, said innovation got contagious. A pilot plant expansion was added to the Umeå factory. Robots joined the party. Twin support began for factories in Brazil, Thailand, the US, Russia. Volvo construction equipment got twinning. Volvo Trucks North America upgraded their aerodynamics and sustainability through reality capture, simulation, and computational fluid dynamics. And today, with their unrelenting allergy to complacency, Volvo is leveraging new tech with different endgames, Gaussian splatting in virtual worlds for human safety. Mys is a Swedish word that roughly translates to coziness and is a pillar of the culture and way of life. You may have heard the Danish equivalent, hygge. Well, seems Volvo has also achieved Mys with staying ahead of the curve. So, what's happening this week? Volvo goes Gaussian for caution, the world's first 100% AI architectural project. A $150 billion company rethinks product shoots with digital twins and NVIDIA Omniverse. Laser and structured light scanning thrilled manufacturers, and an AEC Error of the Week in the 1960s at the height of the high-rise craze. Hit those show notes for some quick caps on NVIDIA open sourcing 3D Gaussian ray tracing and 3D Gaussian unscented transform, a digital twin consortium microfactory use case, Red Bull Racing scanning and 3D printing in Formula One, Public Works pioneers drones as a service, a pod on scaling global end rights through geospatial, and idea curation versus creation in the AI age. And with that, recap number 1. Volvo is making fewer things splat with Gaussian splatting and virtual worlds. You got to admit, Volvo does walk the walk when it comes to generational safety. Company engineer Niels Bohlin invented the modern 3-point seatbelt in 1959. Instead of keeping the patent exclusive, Volvo made it free to use for other manufacturers. 1 million saved lives later, it's often cited as the epitome of corporate social responsibility. And today, as explored in a recent piece by Ars Technica, the Swedish car crafter has enacted the next safety chapter through a suite of jaw-dropping innovation. It traces back to the 1970s when Volvo began visiting crash sites to meticulously record data. Now, with intel from tens of thousands of incidents, Gaussian splatting, AI and virtual world building, and simulation, safety is a sprawling sandbox developers can practically play in. As an early adopter of software-defined vehicles, SDVs, Volvo runs the entire vehicle software stack virtually, enabling quicker simulations and faster innovation. This move is powered by one of Europe's largest data centers, one Volvo itself built, which supports the company's thirst for rapid iterations. Gaussian splatting enhances this by creating thousands of variants in a single real-world scenario, simulating how different conditions affect the car's behavior. These simulations use closed-loop testing with sensor data from LiDAR, radar, and cameras, and employ neural radiance fields, NERFs, built in 4D to simulate these scenarios. It all renders Volvo able to, quote, Take one point, one traffic scenario, and explode it onto thousands or tens of thousands of scenarios from this real-world data, according to Eric Koling, VP of Product at Zenseact, an advanced driver assistance systems developer owned by Volvo. High-ups did confirm that simulating via Gaussian splatting has not replaced testing physical cars on a physical track, but the range of conditions in which testing can occur has grown exponentially. Recap number 2. Archificial intelligence. Behold the world's first 100% AI architecture project. A tale of two cities? Nope. At least not in northwestern Slovenia's Lake Bled, where it's two tales of one city. On one hand, Lake Bled's natural and cultural history is hallowed, with dozens of protected lakes and heritage-listed historic sites surrounding it. On the other hand, it's now ground zero for one of the most modern and imaginative architectural endeavors of our time, delivered by an equally creative firm, Studio Tim Fu, out of London. While Fu's commission puts AI front and center, it's steeped in deeply human values and long-standing Slovenian typologies. In developing the Lake Bled estate, STF employed AI to integrate local Slovenian architectural motifs into contemporary villa designs. The AI analyzed traditional elements and facilitated their reinterpretation into modern features like vertical atriums. The eponymous CEO and, quote, architectural futurist was recently snagged by Forbes for an elaborate interview. He shared his vision for integrating AI into architecture, emphasizing its potential to enhance rather than disrupt traditional practices. Fu's experience, including his time at Zaha Hadid Architects, has taught him the importance of grounding technological advancements in practical realities such as materials and construction. This principle guides Studio Tim Fu's use of AI, ensuring that outputs are feasible and aligned with construction realities. Fu challenges common perceptions of AI designs being chaotic or impractical by showcasing how AI can produce contextually appropriate and structurally viable solutions. He explains how the Lake Bled Estate project aims to set a new standard for luxury and innovative design in Slovenia while honoring the legacy of Jože Plečnik and adhering to strict heritage guidelines. Looking forward, Fu anticipates that AI will simplify the architectural process and unify fragmented stages into a cohesive design-to-construction pipeline, influencing areas such as urban planning and interior design. He urges the architectural industry to embrace AI proactively, similar to how CAD revolutionized architectural practices. Fu believes that the Lake Bled Estate will legitimize AI as an architectural asset by demonstrating its ability to produce practical, appropriate, and by golly, gorgeous solutions. Recap number 3. Deodorant Duet, the $150 billion consumer goods company using digital twins for content creation. Yeah, so a beauty conglomerate spoke at NVIDIA GTC 2025. Yeah, London-based monolith Unilever operates in 190 countries, owning a number of brands over 2x that. That's old news. The new news, an even more riveting form of doubling, came courtesy of Chief Growth and Marketing Officer Ezzy Eggleston-Bracey. Bracey regaled the GTC crowd with tales of leveraging NVIDIA Omniverse to create real-time, pixel-perfect product twins. The platform is crucial for creating realistic 3D models that accurately represent products, including all their variants, labels, packaging, and language formats. Each digital twin serves as a, quote, single digital truth for a product's data. The other tech linchpin here is Open Universal Scene Description. USD ensures compatibility across Unilever systems and suppliers, streamlining workflows and enabling integration of product images into content channels. Now, the numbers, they're staggering. And the most salient ones were pulled from Tresemme, Thailand, as it was the first Unilever company to initiate said twinning. So, 87% reduction in content creation cost, with content generated twice as fast and a 5% increase in purchase intent. Chang, my goodness. And now the efficiency within Unilever is on fire like hairspray at a Rammstein concert. All of Tresemme, along with Dove, Vaseline, and Clear, have integrated this digital twin workflow into their product line content creation. Unilever? When it comes to resting on your laurels, more like Uninever. Recap number 4. Lighten up. Laser and structured light scanning and the twilight of traditional part inspection. Mise en place is an OG French culinary discipline and unsung life hack. Meaning putting in place, it speaks to the value of having all ingredients and cookware prepared and organized prior to cooking. Little did that prophet know he or she also created a metaphor for scanning-enabled virtual assembly, smart manufacturing, and digital twin optimization. Laser and structured light scanning have redefined part measurement, offering bonkers speed and accuracy and a harmonious route to a digital twin. Advanced manufacturing combed through it in a masterful wormhole of a bulletin, taking us back centuries for integral inventions like the micrometer, dial indicator, and CMM before returning us to today's manifestations of them. The piece also benefits from first-hand analysis and wisdom from two authorities at Hexagon and Zeiss Industrial Quality Solutions. Frank Stone, head of sales from Zeiss, explains that manufacturers can now scan physical components and assemble them digitally to ensure proper fit and avoid costly rework. He shares a fantastic case study wherein a tractor manufacturer struggled with blade failures due to unexpected deformations in deck covers. A digital scan immediately revealed the issue. An unnoticed material thickness change was causing interference. Hexagon's Director of Product Management, Joel Martin, emphasizes that digital twins are transforming manufacturing not just by improving measurement accuracy, but by creating a digital thread that connects design, production, and QC. Then there's the duel, lasers versus structured light. So laser scanners offer unmatched flexibility, granting part inspection anywhere in a facility. As Zeiss's Frank Stone notes, handheld units can be used inside a bloody stamping press, with the power off, of course, or directly on a machining center. And beyond inspection, for shops that love them some simulations, laser scanners help build highly accurate 3D models of machine tools, work-holding devices, and tool holders. For precision inspection, however, structured light scanning is often king. Unlike laser scanning, structured light systems capture millions of data points in a single shot, yielding slight upticks in accuracy and speed. They can also scan multiple parts simultaneously. Whether 10 turbine blades or hip implants, software can recognize each part's location and geometry, constructing a 3D image in seconds. This has proven especially valuable in aerospace and medical manufacturing. A cited orthopedic center, for instance, transitioned from CMM-based inspections and cut time from 3 hours to just 45 minutes, while measuring more features with comparable accuracy. Ultimately, laser scanning excels in mobility and versatility, while structured light scanning shines in precision and high-volume inspection. Many manufacturers are finding that a combination of both delivers best results. The time has come, folks. It's your AEC Error of the Week. Some failures announce themselves with time. Cracks widening, lean increasing, warning signs accumulating. Others arrive in an instant, exposing the fragility we did not see, intentional or not. In the early hours of May 16th, 1968, a single spark in an East London high-rise revealed a terrifying truth. Ronan Point was never truly standing, despite the high-rise fervor of the time. It was merely waiting to fall. Ivy Hodge, a resident of the 18th floor, struck a match to light her gas stove. In that moment, a hidden flaw, the kind that lives in shortcuts and unchecked assumptions, came to life. A gas leak, a small explosion, and then, and possibly, an entire corner of the 22-story tower began to peel away like wet paper. The floors above collapsed onto the void below, dragging the structure down in a cascade of failure. By sunrise, 4 lives were lost, 17 people were injured, and the illusion of stability had crumbled along with the building itself. The collapse exposed a chain of negligence disguised as innovation. For starters, a brittle design, no redundancy, no backup, and plenty of off-site prefabrication misjudgment. If one piece failed, there was nothing to stop the dominoes. You had corners cut. Investigators found joints stuffed with crumpled newspaper, ! Instead of concrete. Walls sat on leveling bolts, not the ideal continuous mortar bed. Rainwater had an open door to seep into the joints. Ultimately, it was a perilous gamble. The structure barely met the standards of the day, standards that, in hindsight, were an invitation to catastrophe. It all culminated in a disaster that would catalyze its own demolition just 18 years after opening. The point of Ronan Point? Innovation as prevention. If Ronan Point was a house of cards disguised as concrete, reality capture and related tech could have seen through the illusion before lives were lost. Scanning, photogrammetry, 3D modeling could have exposed gaps in panel joints, misaligned load-bearing elements, and other structural integrity red flags. And when is a drone happier than in the company of a high-rise? Today, as-built versus as-designed analysis ensures that construction matches engineering intent, preventing these hidden weaknesses from being built into reality. A fully integrated BIM model would have revealed the building's lack of redundancy, its weak panel connections, and its inability to withstand localized failures. Simulating real-world forces within BIM would have predicted the progressive collapse scenario, compelling changes before concrete was ever poured. IoT sensors could have monitored structural shifts, analyzed vibrational stress, and potentially detected gas leaks in real time. Instead of waiting for failure, engineers would have seen the warning signs long before disaster struck. Digital twins could have stress-tested Ronan Point's design, simulating explosions, structural weaknesses, and load distribution failures, proving the design's fatal flaws on a screen rather than the real world. Ronan Point forced the industry to reckon with itself, leading to new regulations that demanded buildings be designed to survive local failures without bringing the entire structure down. But the lesson is not just historical. The temptation to cut corners, to do just enough, is as present today as it was in 1968. Reality capture, thorough inspections, and rigorous design reviews exist to counter that temptation, to catch the unseen, to reinforce the fragile, and to ensure that what stands today does not fall tomorrow. Later, recappers. Check out the show notes for those quick caps, like and subscribe to Advanced Innovation while always knowing what's cappening, who's driving it, and the history behind it.